that's it. So we can also use, one of the benefits of this sort of black box philosophy of functions is that we can use other people's functions and not know how it works. I do not know how round works in the math library. I don't want to know. Do not make me learn how the math round function works in the math library. Therein lies madness if you try and understand everyone else's code. So I just want to be able to round it. I pass in some number, it rounds it, it puts it into lib round, right? So the round function will round it down or up. I don't want to have to figure out the rules. I just expect whoever wrote the round function did it correctly. It rounds the number, it stores it in here, good enough for me. And so if we have the math library of functions, we have things like this where, by the way, include math.h. If I need to use the math libraries, I have this line at the very top of my file saying I am including the math functions. And then I can call square root and put in a value x in there. I can take exponent and put a value x in there so I can find out what e to the power of x is. I can say what the log of x is, the natural log of x is. I can say log base 10, figure what that is, right? The absolute value of x, return that. What the ceiling of x is, which is rounding up exclusively. Floor, rounding down exclusively. Power, so x to the power of y. So if I put in 2, 3, it's 2 to the power of 3. Gives me 8. Remainder of with as a floating point number. Right? There's all sorts of different sine, cosine, tan. If you have something that you want to do as a math function, it's probably in the math library. If you put in math.h, you will get those functions available to you, and then you can just use those math functions. So let's look at our function lifecycle. First of all, when I call my function, so if I go back to one of my functions here, like average of 2, when I call the function average of 2, like I did right on this left hand side, when I call average of 2, what happens? Well, first things first, I initialize everything. Every single local variable gets created. All my parameters, that average 1, average 2, or whatever the variables I call them, get created. I make my variables. And parameters are set. So one of them was set to 2, the other one was set to 3. The values are set for those parameters, those variables that are in the rounded parentheses. So when I call my function, I create all my variables. I set everything up. I start things up. In case you're wondering, I wanted a baby being born with the word hello world. That's what Google found for me as an image. So in case you're wondering how I got this image. Number 2, it does a whole lot of work. Why people picking rice in a rice paddy? Because I wanted something that's hard work, and that seems like the hardest job I can imagine, or one of the hardest. Skyscraper window washer is also one of the hardest jobs I can imagine. But picking rice in a rice paddy sounds like a damn hard job. So it does a whole lot of hard work. And then here's the weird thing about a function. At the very end of it, everything dies. So who knows where that image is from? Some of you may recognize it. Some of you are probably embarrassed to recognize it. Some of you are probably far too young to recognize it. This is an image from a movie called The Da Vinci Code, if anyone's ever seen it. There's an unknown actor named Tom Hanks who's in it. In this particular scene, a man ends up being killed by this cult that's going to kill him, obviously, and to send a message. As he is dying, he positions himself into the the classic Da Vinci image of man. I always forget the name of the thing. But he poses himself to give a hint, to give a clue. As these variables are dying, they send out a message. They die, but their value lives on. Their value gets passed back out. So all of these variables that I make with when I create my function, when I call my function at first, all these parameters, any local variables that I make are killed. But a value is passed back out, and that's the important part here. You can send a message out in death. So I create a bunch of variables, I do some work, and then all the variables get destroyed, but a message gets passed back out again. In the case of average 2, it passes back a double. So let's have a look at this one, this particular example. I have a value x which is equal to 4. I'm going to call the function foo with 23 and x, and then afterwards I'm going to add 3 to it. So I'm going to call this thing first. I'm going to call the function first before I can add anything, because I can't add 3 to something that's a big question mark unknown. I have to evaluate foo, then I will add 3, and then sum here will be equal to something. So what ends up happening? X is equal to 4. I go to foo. Foo will then jump up here. I will make a brand new variable called x. Wait, what? I have a variable called x here. I have a variable called x here. But since I'm looking at this function, when I say x, I meant this function's value called x. So the value of x is going to be equal to 23. The value of y is actually equal to whatever the value of x was. The value of x here was 4. That gets passed up. So 23 and 4 is what my x and my y values are. I make a brand new variable called sum. It's going to be equal to 23 plus 4. So now sum should be equal to 27. All right. And then I return sum. Sum gets destroyed, x gets destroyed, y gets destroyed. All of those go back to the system. There is no variable called x, no variable called y or sum after this function is called. But the value 27 is put in place. So instead of foo this, it's actually equal to the value, in this case, 27. 27 plus 3, 30. So sum is equal to 30 at the end. And I'm done. That's what happens each and every time I call a function. I jump up, I make a whole bunch of new variables, I do all this work, and then I jump back down afterwards. And instead of foo 23 and x, I could just say 27 for the value, because that is what sum is. That's the thing that gets returned. The value for this sum, notice though, this is a different variable than this one. They are in different places. One is in the function, one is out here. They are different. Which bolt is that? Point to the bolt is broken. Which bolt? Well, if I'm looking over here, it means this sum. If I'm in here, when I say the word sum, I mean this variable sum. They are different. They both have the same name. Almost invariably, someone in this class is also named David, right? That does not mean you or me. There are 2 Davids as faculty members in the department, and we both are go with full name David even, right? At one point in time there were 3 Chris's. Which Chris are you talking about? Well, if you're talking about the Chris involving administrative things, it's Chris Jocelyn, right? It's contextually based. You can have variables with the same name, and you figure it out based off of where you're looking. If you're looking in foo, and you say sum, you meant the variable in foo, not the other one. Okay. Hopefully one last metaphor, and then maybe we'll take a little break. The other metaphor, in case you wanted to see things in a different way, is cooking. I like cooking. This is, by the way, a strawberry cheesecake cake. If you ever have a chance to look at it, great recipe. Oh, good God, is it filling? It is brutal in terms of just caloric intake and also just how really full you feel. We cut the smallest possible slice we could from these things, passed it to everyone, and no single person finished their piece. It was just that heavy. It is a cheesecake, 2 strawberry cakes, and the whole thing is frosted in cream cheese frosting with some strawberry flavoring to it as well. It is this big ordeal to make. It's very complicated because it involves you making a full cheesecake, 2 strawberry cakes, and cream cheese frosting. The reason I have this there, if you just said a bunch of ingredients for all of this, you would not get that cake. That cake involves another function or another subroutine of making a cheesecake, which is actually a whole bunch of other steps on top of that. It has another recipe for making a strawberry cake, which is a whole bunch of steps on that. You do that twice, so hey, that function called twice. You're making 2 strawberry cakes, and you have a function for making cream cheese icing, and then afterwards you put all of those things together. It's a huge number of steps broken into logical, meaningful steps, logical, meaningful parts. That's what we do as computer scientists. That's what we do as programmers. This Death Star has, I have to look at the box each time, 4,016 pieces. If it was just a big box full of Lego parts with the instructions good luck on it, you would have a hard time, right? That's an impossibility to make, or effectively an impossibility to make. You have a Legos are brilliant for breaking it down into small little steps. You will take there'll be like 5 or 6 booklets to make this thing. Booklet 1, we're going to make this. Booklet 2, we're going to make this part. And then you put them all together later. You do this regularly. We're just doing it programmatically now. We're doing this with using functions. We're breaking big problems into small little chunks that hopefully can be reused, and they don't have cross dependencies. You don't need to know about, when I'm making the cheesecake, I don't need to know about how to make the strawberry cake. They're different things. I want them to be different. There's no like, when you're halfway through the cheesecake, that's the time you have to start the strawberry cake, otherwise everything blows up, right? If you have cross dependencies on these different parts, it becomes unmanageable. If I do half the cheesecake and then half the strawberry cake and then I have to combine them, yeah, you can't do it. And my instructions are based on the context. So when it says put this part on this, what part? It's the part that I had in that bag, the part that I'm working on right now. Right? When it says break open your eggs, which eggs? The one, well, I'm making the cheesecake. It's the eggs for the cheesecake, not the eggs for the strawberry cake. It's contextual. So this is how we're doing it. We're breaking our big problems into small little chunks that you could pull off